I remember when I was learning about factoring in 7th and 8th grade, and my teacher would always just say, just factor it. Just, take something out, just factor it. And she never quite explained what that meant. And my teacher would always just say, just factor it. Just, take something out, just factor it. And she never quite explained what that meant. She didn't allow me to make the connection between factoring and distributing. So if you remember from multiplication, just basic multiplication rules, we have the property that says a times b equals b times a. It doesn't matter what order you multiply. So there's a couple other ones, but they don't really matter right now. The one I'm really concerned about is the a times b plus c equals ab plus bc. The idea that if we have something multiplied by something that's in parentheses, we can distribute the a to both the b and the c. Practical example, if we wanted to do 3 times 2 plus 2, that'd be equal to 3 times 2 plus 3 times 2, which is 6 plus 6, which is 12. So that's a more like concrete example for you to think about instead of just A's and B's and C's. But with factoring, we're doing the opposite. So we'll say we'll have this problem, let's just say 2x squared plus 4x plus 16, which is this little expression right here. And this has already been distributed. It's already in this form right here of the 3 times something plus 3 times something, 2 numbers multiplied plus another 2 numbers that are multiplied. And what we want to do is get it back to this form of having something that you can multiply to each of them and get to where we are already. So if you look at each of these terms, what do they have in common? They're all even numbers, first of all, which means they're all divisible by 2. So that's a good place to start. Do they have like an x in common or anything? They do not. So, well, these two do, but this one doesn't. So what we can do is we can say they have a 2 in common. So we can bring out this 2, where before we like put in a 3 in this way, if we were going backward, we take out a 3, and let's call that bringing out is usually what people say. So we'll just bring out or factor out a 2, and then we'll put a parenthesis. And basically what we're doing is we're taking each of these terms and dividing by what they have in common. So 2x squared divided by 2 is going to be x squared. 4x divided by 2 is 2x, and then 16 divided by 2 is 8. And so now we're back to this form right here where we can distribute and get to where we were. So the distributive property and factoring are just the opposite of each other. Sometimes it's more convenient to have something in this form. Sometimes it's more convenient to have something in this form. And for now, it might seem like a little useless to factor, but once you get into more upper level math, you'll find that, sometimes you need to distribute something in order to solve an equation, or you'll need to factor something out in order to solve an equation. But this is the basic idea. What do the terms have in common in each, what by term I mean each thing that's separated by an addition or subtraction sign. So in this one, let's say 3x squared plus 6x plus 12x cubed. They are all divisible by 3. Obviously 3 is divisible by 3, 6 is divisible by 3, and 12 is divisible by 3. But in this case, they all have an x. This one has 1x, this one has 2 x's, x squared. This one has 3 x's, x cubed, x times x times x, x times x. So it's all multiplied together. So in this one, we'll take out a 3, since they're all divisible by 3, and we'll also take out an x. And then what are we left with? Well, we'll divide each term by this 3x. So 3x squared divided by 3x is going to leave us with just an x, because the 3's will become 1. And then if we have x times x divided by x, one of the x's in the numerator is going to become 1 with the x in the denominator. And then this one, we'll take out, we'll divide by 3 and x, so the x's are going to cancel and become 1. And then 6 divided by 3 is 2. And then this one, we're going to be left with an x squared, and then 12 divided by 3, which is 4. So now, to check this, if we distribute, using the distributive property, this to each of the terms, we'll have 3x squared, yes. 3 times 2 is 6, and then we have it times x, so 6x. And then 3 times 4 is 12, and x times x squared is 3x because of that property of exponents, where if we have the same base and they're multiplied, we'll add the exponents.